बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करेंगे. देयर आर टू रेजिस्टेंस R1 R2 that are connected in parallel and there is error in the measurement of R1 as well as R2. So you can see R1 is 10 plus minus 0.5 ohm and R2 is 15 plus minus 0.5 ohm. So what we have to find is the percentage error in the measurement of equivalent resistance. So most of the students make a mistake here when calculating the percentage error. What they do is that they know that the equivalent resistance will be equal to R1 R2 divided by R1 plus R2. Since these resistances are connected in parallel, this is the formula that we know. And then they apply this formula. Relative error in this equivalent resistance is equal to relative error in this R1 plus relative error in R2 plus relative error in R1 plus R2. Sum of absolute errors in R1 plus R2 divided by R1 plus R2. And then after solving this, what answer you get is 12.33%, but that is incorrect answer. You don't have to use this formula. So what you have to do is that you have to use this particular formula. Okay, 1 upon R is equal to 1 upon R1 plus 1 upon R2. Find the equivalent resistance, which comes out to be 6 ohm. So this is the first step. Find the equivalent resistance based upon R1 and R2. R1 and R2 is 10 and 15. Now to calculate the percentage error, what you have to do is that you have to use this formula again. You have to use this formula and then take the derivative of the both sides. So derivative of 1 upon R is basically minus 1 upon R square into dr, because we know that derivative of 1 upon x is equal to minus 1 upon x square dx. So we are using that formula over here. And the same applies to R1 and R2. So we can see that there is minus minus minus, so that gets cancelled out. Then we have got here dr upon r square. So what we do is that we take 1r on the right hand side. Then on the left hand side, what is remaining is dr upon r. So that will be the relative error in equivalent resistance. We know this value of this dr1 and r1 as well. Similarly dr2 and r2 as well. And then we just fill these values and then we have to do the calculations. So here you might face some problems because in the denominator there is a bigger number and in numerator there is a smaller number. So you might find a little bit difficulty in calculating these values, but after you calculate, what you get is 6 into 0.007, which comes out to be 0.042. So that is the relative error, and then to get the percentage error we have to multiply by 100 both sides. So that comes out to be 4.2 ohm. So that will be the percentage error in calculating of equivalent resistance. So this is how you have to solve this problem. We have to take the derivative of the given formula and not apply this particular method. Okay, so that is incorrect.